Hello friends, welcome to Internetworks. My name is Edgar Francis. In this video, we are going to see why do we need an IP SLA and how to configure IP SLA. You can see the topology. First, we assign the IP address as per our topology. Then we assign the IP on the PCs, PC1 and PC2. After that, we are going to configure our default route from router 1 to ISP1 and make this interface link as a primary. And then we configure the default route between router 1 and ISP2 and make this serial 2/1 as a backup link. After that, we are going to configure a static route from router 2, router 3 and router 4 and verify the backup link between router 1 and ISPs. After that, we are going to see why do we need an IP SLA. In the end, we will make sure that the backup link will work even if the ISP site link is down. This link is down. One of these links is down. We want that backup link will work. So starting from the assign the IP addressing from router 1. Router 1. Let's go terminal. Router 1 is having 3 interfaces, 2 serial, 1 fast Ethernet. Now router 2. Router 2. Configure terminal. Router 2 is having 2 interfaces, 1 serial, 1 fast Ethernet. Now router 3. Terminal. Now router 4. Configure terminal. Router 4 is having 3 fast net. After this, now we are going to configure the default route from router 1 to ISP and make the interface primary. And also we are going to configure the default route from router 1 to router 3 and make this serial 2/0 as a backup link. Router 1. You can see the IP dot 0.0.0, mask 0.0.0, next stop 1.1.2, this interface, and IP dot 0.0.0, 0.0.0 mask, and the next stop is 3.3.3.1, and the AD is 12. Now this link is a backup link. Now let's configure the IP address on the PC1 and PC2. IP 10.1.1.2, mask 255.0.0.0, the default gateway is 10.1.1.1. You can see we're checking for the duplicate address. In the meantime, we are going to configure on PC2 IP route, IP 20.1.1.2, the IP address, mask 255.0.0. Next stop, the default gateway 3.1.1.1. Checking for duplicate address. Show IP all. You can see on PC1. Show IP all. Okay. Now we are going to configure the static route from on router 2, 4 and 3. Router 3. Router 3 is acting as an ISP1. You can see IP dot 10.10.0.0. The next stop is this 1.1.1.1. And the 40 dot network next stop is 2.2.2.2 here. Okay. Now router 3. On router 3, IP dot 10.0.0.0, Next hop is 3.3.3.2 this length, and IP.40 network. Next hop is 4.4.4.1. Now router 4. Okay. IP.10 network. In order to reach from router 2 is having two paths. One is 2.2.2.1 and another one is 4.4.4.2 via router 3. Okay, now let's verify the IP addressing and the static route. Starting from router 1 to show IP interface brief. Everything looks good. Up, up, up. On router 2 you can see both interfaces up. Router 3, both the interfaces up. On router 4, router 4 is also looks good. Now starting from router 1 to show IP route static. You can see the default route here. We made this the serial 2/0 means 1.1.1.2. The primary interface router 2 is using this serial interface serial 2/0 on router 2. So IP route static. You can see router 2 having the static routes in the routing table. Show IP route static. Okay. On router 4, you show IP route static. You see, in order to reach the 10 network, router 2 is having two paths via router 2 and router 3. Okay, let's think from PC1 to PC2. From here 10.1.1.1.2 to 40.1.1.2. PC1 here 10 40.1.1.2. Timeout, 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 timeout. Okay, let me verify. Okay, this is happening because I put the wrong IP address on this PC2. Let me correct it. So start. Okay, IP 40.1.1.2 mask preferred for 0.0.0. The default gateway is 40.1.1.1. Checking for duplicate address. Now we are trying to ping again. You can see the reply is coming from 40.1.1.2. Let's verify from somewhere on the internet. PC2 ping 10.1.1.2. Okay. As you can see, everything is working fine. Now from router 1 we want to trace route 40.1.1.2. Let's see. Okay, router 1 is using our primary interface, which is here. serial 2/0 and then fastnet 1/1 in order to reach 40.network. Now what we are going to do is we are going to shut down the serial 2/0 to make sure that router 1 will use backup link if the primary link is failed. So from router 2 we are going to shut down this link. Okay. Interface fastnet, interface serial 2/0 shut down. See the message here. Administratively, this link is shut down. Now we are trying to ping from PC1 again. Timeout, 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 timeout. It will take some time to install the routes. Okay, you can see the message here after the whole time. Trace routes 40.1.1.2. You can see our router 1 is using our backup link. Before it used this primary link. Now in order to reach the 40.net network in the failover of this primary interface, router 1 is using the backup link here. Again, this route you can see. Now from PC1, let's try to ping again. You can see the reply is coming from 40.1.1.2. Let me show you something. Show IP route static. You can see now is using the 3.1.3.3.3.1 IP address, means next hop. Let's bring the interface up again. Node shut down. Exit. Now the question comes, what will happen if the interface between ISP1 and router 4 means fastnet 1/1 goes down? What router 1 will use the backup link or not? So let's verify it. First we shut down the fastnet 1/1 to verify it. Interface fastnet 1/1 shut down. You can see the link is shut down. Now again we are going to ping 40.1.1.2. You can see unreachable. Okay, trace routes 40.1.1.2. You can see unreachable, and it's using our primary link from PC1. Of course, it will time out. You can see the destination host is unreachable. Why? To show IP route static. You can see our router 1 is still using this primary interface, even the link is down, the fastnet 1/1, and router 1 is having no idea because this is the ISP side problem. But our company router 1, is still using this primary interface in order to reach the internet. So here we need an IP SLA to track down the end-to-end connectivity. So let's configure the IP SLA and we will see our backup link will work even these link goes down. So first we are going to make this link is up. Shut down. Exit. Okay. Router 1, configure terminal. We are going to configure IP SLA on router 1 or company router. Okay. You can see the command here. IP SLA 1 echo 40.1.1.1 from here to this. Frequency threshold exit. You can see the data IP SLA state down to up. Now it's checking. Let me shut down. Exit. No IP route 0.0.0 and 1.1.1.2 and the track 1 we use here. You can see here track 1. Sorry. Now again we are going to shut down this interface and we will see router 1 will use this backup link or not. On router 2, interface fastnet 1/1 shut down. Router 2, router 1, we will see the message hopefully like this. You can see the tracking state IP SLA 1 state up to down. Up to down. You can see the IP SLA state down to up means this length. Let's ping from ping 40.1.1.2 timeout. You can see the reply. On router 2, you can see the show IP interface here. You can see the fastnet, this link is still down, but our PC can ping from router 1 to somewhere on the internet 40.1.1.2 network. You can see the trace down command. Trace down 40.1.1.2. You can see our router 1 is using the backup link even if the ISP side link is down. Okay. I hope you like this video. Show and show track. Sorry. on router 1. Show track. You can see status up and show IP SLA statics. You can see CCNP operation, number of failure, number of success, and I hope you like this video. If you like this video, please give a thumbs up, and soon you will get the new playlist of quality of service and SD-WAN. Thank you so much for watching this video.